In this video, I will explain you working of transformer and transformer equation, derivation of transformer equation. Okay. Now, transformer is a device that is used to either step up the voltage or step down the voltage of a AC circuit. So, I have told many things in this statement. So, one thing is transformer can only be used in AC circuit. Okay, so when an AC output is given, then we can step up the AC, which means if 220 volt supply is given, I can make it 1000. Okay, and I can also do the reverse process. When 1000 is given, I can step down to 220. Now we will see the definition. A device which can change potential difference and current of AC supply. Now here, this is the potential difference of the source we have, and that can now be changed to a different value. So when the potential is changed, then accordingly current will also change. We will see the construction. First thing is principle. Principle is very simple, mutual induction. Now AC current means the current would increase from 0 and become maximum value, then decreases to 0, increases in opposite direction and decreases to 0. So this is an alternating current. So this, when applied on a coil, what will happen? There will be a magnetic field created around this coil. Okay, so that field starts from 0 and increases to a maximum value, then decreases to 0. Now the magnetic field will become opposite in direction, increases to maximum value and decreases to 0. According to current, the value will also increase and decrease for the magnetic field. Okay, now this field lines are linked to a secondary coil. So basically this structure is in this way. We have core in this way, soft iron core, and primary would be wounded, or this coil would be wounded on a core, and on the same core we would be winding the secondary. So you know, this induction would be more. So for the better explanation, I have kept primary and secondary in this way. So primary is our input, secondary is the output. Okay. So anyway, mutual induction, that is whenever current through one coil changes, magnetic flux around that will change, and this magnetic flux is linked with a different coil. So this will induce an EMF, because the magnetic flux linked with this coil changes at every moment, and that will induce an EMF in it, and that is called as, you know, mutually induced EMF. So that is the working principle. Part soft iron core. So we have an iron core and we have copper winding. Now why I have kept an iron core? Because when magnetic field lines have two different paths, that will choose the one that is having maximum permeability. Now see, this is soft iron core, and soft iron cores is a ferromagnetic substance. So out of all the magnetic field around this coil, that would choose to go through this path, because that is the lower resistive path or having highest permeability. So field lines would choose this path. So whenever we are keeping a soft iron core near to this, maximum amount of magnetic field lines would be passing through that coil. So when I am keeping in this way, I can make sure that there is no flux linkage. So if at all flux is produced to this side, then that is basically wastage. Correct. We have no use with flux in this side, because we don't have any secondary coil connected here. So the secondary coil is connected here. Now we need the maximum flux produced by primary coil to be linked with the secondary coil. So that would be possible if I am keeping the windings on a soft iron core. Okay, so that is soft iron core, and I have copper winding. So this is winding that has got almost zero resistance. So that is the meaning of copper winding, that is conductor got zero resistance, approximately I am saying. Now working principle, I have told initially, right? Current passing through, that will change, varies, that will create magnetic flux around it. Now the flux will also change. Whenever the flux changes, this flux is being linked with the secondary coil, and whenever flux linked with the secondary coil changes, then that will induce an EMF in it, that is mutually induced EMF. Okay. Now the flux produced by the primary coil will also link with the same coil, and that will create self-induction. Okay, that is self-induced EMF. Now, so let's say we have applied a voltage of E. So E is nothing but E Em sin omega t. As it is alternating, this will induce a self-induced EMF or a back EMF in the same coil. What would be the value? So EMF induced in the primary coil would be, as per Faraday's law of electromagnetic induction, with one coil that would be d phi by dt. And this flux changes in primary. Okay. And as there are n number of turns in primary, I can mention it as np into d phi p divided by dt minus. Lenz's law is the meaning for minus sign. Okay. This minus induced means that the induced EMF would be such a way that will oppose the external EMF. Anyway, minus np d phi by dt would be the induced EMF in coil number, that is in the primary coil. And in the secondary coil, the induced EMF would be, in one coil it would be d by dt of, or d phi by dt. Now the flux is produced by the primary coil, so it would be the same change in flux here as well. So that would be d phi p divided by dt. See, at only through primary coil we are sending the current, so that is creating a d phi by dt due to primary coil across it. So the same change is linked with the primary coil as well as secondary coil. Okay. Now this is with one coil, but secondary is having ns number of turns. So ns I will keep it capital number. Okay. Np here, ns, and this is as per Lenz's law. So this is as per Faraday's law of electromagnetic induction. Yeah, electromagnetic induction. Faraday's law. And this is self-induction, this is mutual induction. Now we know that d phi p divided by dt, in both the equation it is the same. Okay, so working as per the first equation, I would get d phi p divided by dt is equal to minus ep divided by np, and as per the second equation I would get d phi p divided by dt is equal to minus es divided by ns. Now I can equate these two because these are the same quantity, d phi p divided by dt and d phi p divided by dt, that is minus ep by np is equal to minus es divided by ns. Minus minus will cancel. Now I can say that es divided by ep is equal to ns divided by np. This is a very important relation. See, es is EMF in the secondary divided by EMF in the primary is equal to number of turns in secondary divided by number of turns in primary. I will give you an illustration. For example, the input is 200 volt and input is having a total number of 100 turns. Now if output, that secondary is having 500 turns, what would be the EMF across secondary? So we will use this equation. EMF across secondary is equal to EP into NS by NP. EP is EMF in the primary is equal to 200 and NS is 500 turns divided by NP is 100 turns. So this value will be 1000 volt. See, when I have given 200 volt, I have got 1000 volt in the output. Now if I am giving 1000 here, that will be delivering 200 here. So see, when the number of turns in the secondary is more than the number of turns in the primary, then that is step up. See, stepping up. Now when number of turns in the secondary is less than number of turns in the primary, this is step down transformer. So step up and step down means that in output the EMF would be more than input, that is step up. In output the EMF is less than input, that is step down transformer. Now we got to know that the voltage would be different. In the next video we will see why we are using transformer and how does this output voltage effect in the total power and also in the efficiency and also in the current of transformer. Okay, thank you.